Hello students, this is Mrs. A and you are in my kitchen. This is our first flipped video assignment. I will probably do another one for 3.1 just to help those students that missed the first day, but I'm going to get 4.1 done first because everybody needs to watch that one. We will not have a quiz on this material until Thursday because I'm getting it out pretty late. I meant to get it out over the weekend, did not do it. So this is the first thing that you're going to need to remember. When you come in to a video, this one and all the ones that are following it, you're going to do three things while you're taking the video. Number one is you're going to sign in. To sign in, you're going to leave a message on the video, which is on YouTube. You just leave a message on the video and it will say, hi, your first initial, last initial. Whoops, it's going to say either 9 or 12. If you're in my 9 o'clock Tuesday, Thursday class, you put a 9. If you're in my 12:30 Tuesday, Thursday class, you put a 12. 12 is good enough for 12:30. And then you're going to put first initial, last initial, and then the last two digits of your college ID. Okay? So you're just going to say hi, 9SH, and then whatever those two digits are. Okay? And then at the end of the video, after you've done the video, you can rewind as many times as you want. You are going to say, you can make another little comment, and you're going to say, bye. And you're going to put the same number that you had before, whatever those last two digits are. That way, I have in there when you said hi and when you said bye. Okay, now, you also are going to take very ample notes because your quiz is open note. So you will have a quiz over every flipped class, and that quiz is open note. So you want to make sure that when you sit down, you sign in, you take ample notes, you sign out, and that'll do it. Okay, so we're going to start our first section on 4.1, and I will be back shortly. Okay, so now we're starting 4.1 on Messer-Smith's Intermediate Algebra, and we're going to flip back and forth between me and my little board, okay, and the screen of the PowerPoint. So it's going to be kind of a mush together, but I think it will be adequate to get the point across because I'm teaching you on the screen instead of in front of the classroom. This is a flipped assignment, so you want to make sure that you are signing in, signing out, and taking notes as described earlier. And now we're going to look at our PowerPoint. All right, so you can see that this is chapter 4, and we're talking about linear equations in two variables and functions. The one we're working on today is the introduction to linear equations in two variables, which is 4.1. And these are the items that we're going to be talking about in this section today. All right, so the first thing we need to talk about is our Cartesian coordinate plane, or sometimes called rectangular coordinate grid. And we have our origin here. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. They're always going to use Roman numerals. I don't know why. But we have the x-axis and the y-axis. So you should be familiar with this already, very familiar with this. This is just a review. Okay, so here when we're trying to plot points, we're going to go right 4 up 2 to plot the point for 2. All right, so let's look at each one of these points that they've given us on the PowerPoint. Negative 2, 5 is left 2, up 5. 1, negative 4 is right 1, down 4. It winds up in quadrant 4. C, 7 halves and 3. Well, first we have to realize that 7 halves is 3 1/2. So it will be from the 0, 0, right 3 1/2 steps and up 3 steps, and it winds up in quadrant 1. Negative 5, negative 2 is back 5, down 2. So left 5, down 2. It winds up in quadrant 3. 0, 1.5 is what we call a quadrantal because it is going to wind up on the axis. Okay, so 0, 1.5 winds up on the y-axis. Okay, negative 4, 0 is going to be negative 4, and then up or down 0, so it's going to be right on the x-axis. A solution of an equation in 2 variables is written as an ordered pair so that when the values are submitted for the appropriate variables, we obtain a true statement. Decide whether an ordered pair is a solution of an equation. All right, so now we're given 2 points, negative 1, 3, and 3 halves, 5. And we are going to decide first if negative 1, 3 is a solution of the given equation. 4x plus 5y is 11. So here is our equation. 4x plus 5y is 11. And now in place of the x, we're going to stick the x coordinate. The x coordinate is negative 1. So notice we have our little parentheses to keep our negative 1 kind of in a little cocoon there. And so we have 4 times negative 1. 5 times, instead of the y, we're going to substitute in the y coordinate, 3. So that's 5 times 3 is 15. So 4 times negative 1 is negative 4. 5 times 3 is 15. Negative 4 plus 15 is 11. Remember, when we're adding signed numbers, we add opposite signs. We really subtract the 2 absolute values and take the sign of the greater. And 11 is 11. Since we started out trying to get it to be 11 and it was 11, it is a solution, and we say that it satisfies the equation. So now we're looking at the B solution here to see if it is a solution. So we put 4x plus 5y is 11. In place of the x, we put the 3 halves because it is the x coordinate. In place of the y, we put the 5 because it is the y coordinate. And then we do this multiplication. Remember that 4 can always be 4 over 1. And then we've got 12 halves, which is 6. Or you could cancel 4 and 2, leaving a 2 upstairs. 2 times 3 is 6. Plus 25 is 11. 31 is not 11. Therefore, the ordered pair is not a solution to the equation. So here we're talking about graphing a linear equation in 2 variables by plotting points. So basically they have given us a list of points over here, okay? And this list of points over here is showing all of the points that make the equation true. Okay, so now we have to go through the process of finding those points and verifying that they are indeed solutions to where 11 is 11. Okay, so we find out that they are solutions by the previous method, and then we make a little grid. This is an XY grid. You'll hear me talk about an XY grid. And then we're going to actually plot each point. So negative, left 1, up 3. Right 4, down 1, right 4, down 1, right 9, down 5, right 9, down 5, and so forth. So we're going to plot the points and draw the line. A linear equation in two variables can be written in the form ax plus by is c. We call this the standard form of the line, where a, b, and c are real numbers and where both a and b do not equal 0. Now I hope you can see that if both a and b equaled 0, we would wind up having no variable in our equation at all, and it would not be a line. So we have to have either an x or a y or both. So here we have an equation that we're going to graph. So here's my equation right here up at the top, and I'm going to find out what y value goes along with x is 0. So I'm going to plug in x is 0. So right here into my equation, we plugged in x is 0. And then that just left a negative 0. So I still had 2y is 4. Or divide by 2, y is 2. So 0, 2 is a solution. Okay, so then I come over here to the next one and we're going to plug in x is 2. So here's my equation. Here's what it looks like when I plug in x is 2. Then I'm going to add a 2 to both sides to get rid of the 2. So add 2, and I get 2y is 6, or y is 3. So 2, 3 is a point that solves the graph, or the equation. And lastly, we're going to plug in a negative 4. Now, when we have a negative 4, remember that becomes a positive 4. When we take away 4 from both sides, we get 2y is 0, or divide by 2, y is 0. So negative 4, 0 is another solution point. So these are the 3 solution points that we got when we were plugging in, and now we'll go to see what happens when we plot those. Right here we have the same 3 points, and 0, 2 is on the y-axis, 2, 3, and negative 4, 0 is on the x-axis. Now, we got our line, but I want you to look for a minute. Notice that this point, 0, 2, winds up on the x-axis. So, could you say that if you wanted the place where your line crossed the x-axis, the y-axis, that you would let the x value or the x coordinate be 0? Okay, look over here. For the point or the place where the line crosses the x-axis, we let the y be 0. And we're going to find shortly that that is our definition of our x and y intercepts. To find your y-intercept, we let x be 0. To find our x-intercept, we let y be 0. And there are your definitions right there. The x-intercept of the graph of an equation is the point where the graph intersects the x-axis. The y-intercept of the graph of the equation is the point where the graph intersects the y-axis. To find the x-intercept of the graph of an equation, let y be 0 and then solve for x. To find the y-intercept of the graph of the equation, let x be 0 and solve for y. Easy, easy, easy. Okay, so here we go. We are going to graph by finding the intercepts and then one other point. Okay, so here's our equation, and I'm just reminding you here that when we want the x-intercept, we let y be 0. When we want the y-intercept, we let x be 0. to find the x-intercept, we will substitute in for the y a 0. So here's my y. It's the first thing. It's going to become a 0 is equal to negative 1/2 x minus 1. All right, now, to solve this, we're going to add a 1 to both sides. So when I add a 1 here and I add a 1 here, can you see how this one is going to be 0 plus 1 is 1, and negative 1 plus 1 is going to be 0. So I wind up with negative 1/2 x is 1, but if I multiply both sides by negative 2 and negative 2 on the other side, then I'm multiplying by the same thing, and what do I get? Negative 2 times 1 is negative 2. And then negative 1/2 times a negative 2 becomes a positive 1. So that cancels this out. And I wind up with x is negative 2. So now for my x-intercept, I'm going to go back up here and put in the value that works for the x-intercept, negative 2, 0. For my y-intercept, I let x be 0. So here's my equation rewritten with x is 0. Well, negative 1/2 times 0 just becomes 0. And then I have y is negative 1. So for my y-intercept, a negative 1 goes right here. And we've done 2 of our points. So now we could pick one other point. And I like to pick friendly points. So I'm going to pick a 2. All right, if I pick a positive 2, then the 2 and the negative 1/2 will cancel with a negative 1. So let's plug in a 2 right here to find out what that value is going to be. So we're going to move it up a little bit. We're going to plug a 2 in right here for the x to find this third point that we need. And then negative 1/2 times 2 is negative 1. Take away another 1 is negative 2. So the point is 2, negative 2. And that is the third point that we need. So we have 3 points now. Negative 2, 0, 0, negative 1, and 2, negative 2. So let's go over here and see what our PowerPoint is going to do for us. Okay, so here we go with, they're plugging in the 0 for the y, just like I did. Right here, they're plugging in the 0 for the y, and they're cranking out a negative 2. So negative 2, 0, and remember we had negative 2, 0 down here. So then they plugged in for the x a 0, and they cranked out a 0, negative 1, and we also had a 0, negative 1. So all is well. Now, they also picked the same point. I didn't know they were going to do that. But, again, they're picking a friendly point. And a friendly point is going to get rid of that fraction. So having an even number is important. And they happen to pick the same even number I did. So now we've graphed the 3 points, and you can see the graph of the line is very easy to do. So now let's look. This is section 5 of 4.1. Graph linear equations of the forms x equals a and y equals b. What do you do when one of your variables disappears? Okay, so here we have the graph of the line x is equal to 3. And I actually had to do this when I was a much younger mathematician because I'm a little bit dyslexic, and I could not remember whether an x line went up and down or left and right. So an x line winds up being a vertical line, and we'll see in just a minute that a y line winds up being a horizontal line. But a good way to graph this line is just to put 3, 3, 3, because x is 3, in some slots here, and then replace y with any number you want to. And plot those points, and you will see that it makes a vertical line. Okay, so the graph of x is equal to a. If x is a constant, then the graph of x is equal to a is a vertical line going through the point A0. All right, so it is crossing at 3, 0 is what they're saying here. The point 3, 0 is one of the points. All right, so here we have a y line. Y is -2. So now what are we going to do? We're going to take our y column here in our grid, and we're going to make it -2, -2, -2. Y is a constant, -2. And then we're just going to put some points, any points we want, in the x column. We're going to plot them, and we're going to see that the graph is a horizontal line. So y graphs wind up being horizontal lines. The graph of a y equals b. If b is a constant, then the graph of y equals b is a horizontal line going through the point 0b. And if you look, 0b, okay, 0, -2 is a point on this line. Now, we're coming to the midpoint formula. The midpoint formula is a halfway point between two other points. So, if x1, y1, and x2, y2, now this is mathese for just designating 2 points, okay, on the plane, any 2 points on the plane, are the endpoints of a line segment, then the midpoint of the segment has coordinates. Now notice, they said segment, not a line. A line does not have endpoints. A line never ends. It goes on forever and ever in both directions. Amen. But a line segment ends, and a line segment would have a midpoint. So notice how my x value of my midpoint is just my x and my x added together and divided by 2. Does that remind you of something? Maybe an average? Okay, so the midpoint is the average of the 2 x's will be the x value of the midpoint. Wow, that's easy. Okay, the average of the 2 y values will be the y value of the midpoint. So you add them together, divide by 2, add them together, divide by 2. That's all there is to it. Okay, the midpoint formula is here. They're showing you where the midpoint winds up, exactly halfway along the path of the line from the first point to the second point. It is what it says, a midpoint. Right, so here we have 2 points. We have a -3, 4, which is here, and we have a 1, -2, which is here. And we're trying to find the point that is exactly on the line halfway in between those two. And we add the -3 and the 1 together and divide by 2. We add the 4 and the -2 together and divide by 2. And we end up with -3 plus 1 is -2 divided by 2 is -1. 4 plus a -2 is 2 divided by 2, which is 1. And it does look like it is right in the middle, doesn't it? All right, so now we're going to work on applications. So the length of an 18-year-old female's hair is measured to be 250 millimeters, almost 10 inches. The length of her hair after X days can be approximated by this equation here, where Y is the length of the hair in millimeters. Find the length of her hair 10 days, 60 days, and 90 days after the initial measurement, and write the results as ordered pairs. Graph the equation. How long would it take for her hair to reach a length of 274 millimeters, which is almost 11 inches? Remember, she started at almost 10 inches, but we're doing this problem in millimeters. So here is the solution. X is the number of days after the hair was measured. Y was the length of the hair in millimeters. Okay, so notice that she started with her hair being measured at 250 millimeters. Okay, so of course, the amount that the hair grows, the length it's going to be after this number of days is going to depend on where it was to start with. So here we go. We're going to plug in. Remember, it said 10, 60 were the first two that they asked for. So we're going to take X, the number of days after the hair was measured, and we're going to let the X be 10. Now 10 times 0.3 just moves. Remember, when we multiply by 10, it moves the decimal one step to the right. So we end up with 3 plus 250 is 253. So 253 millimeters will be the length of the hair after 10 days. After 60 days, we plug the 60 in for the X, and 0.3 or 0.30 times 60 is 18, plus the 250 that it was before we started the little experiment, and we end up with 268 millimeters worth of hair. And lastly, after 90 days, 90 days is almost 3 months, okay? It's going to grow 27 millimeters and will be 277 millimeters. So now we know those three. Now that is the A part of the problem. Let's look at the B part of the problem, okay? Now we put our 3 points on a line. That's our graph of the solution. Now notice that we started the experiment when the hair was a length of 250 millimeters. Now this is called a broken graph. We have a little zigzag there to show, hey guys, this did not start at 0 to begin with, and because we don't want to have this graph take up way too much room, we're just going to put our days down on the bottom, 10, 20, 30, 40, 50, 60, 70, and so forth. And we're going to start where we started in our experiment, and we're going to graph from there. And that little broken line is an indicator that this is not a true measure here. It does not follow the rest of the scale. And then C, it says it will take how long for her hair to grow to a length of 274 millimeters. Now, they're not giving us the amount of time, how many days. They're giving us a desired length. So now the Y is the desired length of the hair. So we're going to put the 274 where the desired length of hair is. And now if we subtract 250 and we subtract 250 from both sides, then we're going to get 0.30x. 274 minus 250 is 24. If we divide by 0.30 on both sides, we find out that it takes 80 days for her hair to grow to a length of 274. Okay, so now I'm just going to show you a couple of example problems that could be on your quiz. So the first one we're going to do is, here is an equation of a line, 3x plus 4y is -2. And we're going to check and see if these 2 points are or are not solutions to the equation. So when we're looking at 2, -2, we're going to take our equation and plug in everywhere we see an x. We're going to put in a 2 because we're plugging in a 2. The y we're plugging in as a -2, so 4 times a -2. And then I usually put a little question mark up there, say, hey, we're trying to see if it's equal or not to the -2. So when we crank this out, we get 6 plus a -8 is indeed a -2. So the check mark says that it is a solution. Then we do this second point over here, 3x. So instead of the x, we'll put in a 1. Plus 4y, instead of the y, we'll put in the 5/4 that we're supposed to put in here. So 3 times 1 is 3, 4 times 5/4 is 5, and 3 plus 5 is 8, not negative 2. So no, this one is not a solution. So I put a big X saying it is not a solution. Okay, so now another example is we're going to start out with an equation. X minus 3y is 4, and we're going to try to graph it using our X and Y intercepts and one extra point. Okay, we have an X-intercept. To get our X-intercept, we let Y be 0. To get our Y-intercept, we let X be 0. And then we need 2 points to make a line, but we need another point to check it and make sure that we have it right. So we always get a third point before we consider ourselves done. So here we go. We're going to let X be 0. So this one's going to be the Y-intercept. When we let X be 0, then X is 0. There's my 0. I'm just copying the rest of the problem down. Then the 0 just goes away. I divide both sides by negative 3, and I get Y is negative 4/3. Okay, so the point becomes 0, negative 4/3, and again, that is the Y-intercept. So then here, we're going to let Y be 0 to find the X-intercept. When I plug in Y is 0 here, this whole part goes away, and I end up with X is 4. So the point is 4, 0, and that, since the Y is 0, is my X-intercept. So that's 2 points down, and I rewrote those 2 points here on this board, and here we have the 2 points, and now we're going to find one more point to check to make sure our line is correct. So now here's my equation. I'm going to let Y be 1. I'm all about trying to get friendly numbers, and if I let Y be 1, then I end up with X minus 3 times 1 is 4. 3 times 1 is 3, so X minus 3 is 4. I add 3 and I add 3 to both sides of the equation. I get X is 7. So that point is 7, 1. Here it is. And then we're going to go and graph them. So here are my 3 points written on a board. Oops, I didn't realize my line was so crooked, but hopefully you can get the right idea. And 0, negative 4/3. Now negative 4/3 is negative 1 1/3. So here's 0, negative 1, and we'll put it about right there. Okay, and then 4, 0 is going to go over 4 and 0. And then the last one is 7, 1. So 1, 2, 3, 4, 5, 6, 7, 1. And they do look pretty much like they're on a straight line. So we would make a straight line going through. Hopefully on your papers you will have a nice straight edge. I did my best. Okay, so we'll be back with a couple more examples and then we'll be done. All right, so here we are at the very end of our lesson, and we're talking about graphing lines that just have an X or just have an Y. So here at the top we have an X equals 7. So we have our little rectangular coordinate grid, and that just means that every single X on the line will be 7. So you can just go ahead and fill in a bunch of 7s here for your X's, and then you can put anything you want over here. You could put negative 5, 0, 5 to spread our points out nicely. Okay, so that means that negative 5 here, it's 7, excuse me, 1, 2, 3, 4, 5, 6, 7. We're going to have 7, negative 5, which be down about here, 7, 0, and 7, 5. So all of them lie in a straight line, and that line is called X equals 7. Okay, then we do a Y line. Y is negative 5. So over here on our rectangular coordinate grid, we're going to put negative 5, negative 5, negative 5 for all of our Y's. And then we could put negative 2, 0, 2. Any points will do. Okay, I'm just spreading them out a little bit. So negative 2 is right here, negative 2, negative 5. We'll make that negative 5 right there. 0, negative 5, and 2, negative 5. So we'll say that's 2 right there, negative 5, and Draw your nice little line across. And this line is, y is -5. So you can see that x lines are vertical and y lines are horizontal. Okay, the next thing we want to do is our midpoint. And remember, a midpoint is an average of the two x's and an average of the two y's. So the x value of the midpoint is going to be the average of the two x values. So here we have an x value, -2, and an x value, 6. So -2 plus 6 is 4 divided by 2 because we're averaging. So we end up with 2. So the x value of the midpoint is 2. And then we add the -5 and the 3 together. And we get a -2 divided by 2. We get a -1. So the y value of the midpoint is -1. Okay, so now hopefully when we graph it, this point to -1 will be exactly halfway from -2, -5 to 6, 3. Okay, so here I have graphed our points. These were our two endpoints here, and this point to -1 is exactly halfway. It is on the line segment, but it is halfway from one point to the other, and that's what a midpoint is. And this is Mrs. A. Don't forget to leave a comment below and put your end of the class information, which is going to be, remember what you're going to write. You're going to write by, and you're going to write whether you're in the 9 o'clock class or the 12:30 class. By, if you're in the 9 o'clock class, you'll put a 9 in the front. You'll put your initials and then the last two digits of your student number, so I will know that you checked in and said goodbye on the video. And you will see a quiz on this in a couple of days because I was late getting this online. So your quiz for this one will be on Thursday instead of tomorrow. And I will see you in class tomorrow. God bless.